All right, so the text for this video will be either above or below the video. So I'm not going to write everything out here. I'll just sort of cut to the chase. This is the problem talking about the diameter of dimes. So there's a machine producing these, and we're basically trying to figure out, is the machine, has it slipped out of adjustment? And that wording is kind of important because it says, has the machine slipped out of adjustment and the average diameter is no longer 1.9 centimeters. So that tells us quite a bit of information. Namely, it allows us to define the null and alternative hypotheses. So right now, the mean for dimes, or the supposed mean, is 1.9 centimeters, right? This 1.9 is our mu naught, sort of the assumption, the assumed value, the value it is set to. And if we're just wondering if it's slipped out of adjustment, that doesn't mean we think the diameter has increased or decreased. We're saying that we think mu might be something other than 1.9. So that means that we're dealing with a two-sided or two-tailed alternative. That's going to be important, right? That affects our p-value when we get there. So the other pieces that we have in this problem in particular are that x bar, right, the sample mean was 1.89 centimeters. We found that from a sample of 64 dimes. So the good news is our sample size is fairly large. We have a random sample of 64 dimes, so all of our conditions are met. In the video where we did a Z test, a one sample Z test, I kind of walked us through all of the steps individually. So checking the conditions, finding the test statistic, all of those pieces. I'm going to cut to the chase a little bit here because largely we're going to be using the TI-83-84 function where we just plug in the important pieces we need, like what does the null and alternative look like, what's the sample mean, how large is the sample. And then this other piece of information, though, is the big one. If we're asking ourselves, are we using Z or T, right? That's the big question because we know S in this case, the sample standard deviation, we're going to use T. So this is how, again, how we know. If we have sigma, the population standard deviation, we use Z. If we're going to use S, the sample standard deviation, we use T. So in this case, S was 0.05. So we want to find what our p-value is. We're going to compare it to a 5% significance level. So that means alpha is 5%, or another way to say that is 0.05. Again, what this is our cutoff. If we have sample results, so this 1.89, if results like this occur less than 5% of the time under the assumption that the null is true, right? This is our assumption. So if we have sample results that occur less than 5% of the time, that's evidence enough. It's statistically significant evidence to say something is wrong here. That null does not seem to be true. So let's go find our p-value. We're going to find this using a tool in our 83 or 84 TI-83-84 calculators. So we're going to go to Stat, Tests, and there are a bunch of tests here, but we have a one sample t-test, so that's just going to look like t-test. Should be the second thing listed there. And if we put in all of the information that we've got, it's going to give us a p-value. So again, one of the key things is make sure you've got this two-sided, so make sure you're choosing the not equal to value. And mu equals mu naught. So again, mu naught is 1.9. X bar is 1.89. We can have a little visual of that too, might be helpful. So here's 1.9, what we're assuming to be the mean. Our sample mean was 1.89, so that's mu naught and X bar. And we want to know what's the likelihood of getting results over here But also because it's two-sided, we're going to include this side as well. That's the big difference, right? This might give us a p-value that's less than our alpha of 0.05, but maybe when I have the two sides, it's bigger than alpha. So having one-sided versus two-sided can make a difference. Do we reject the null or fail to reject? So if we run through this process, we should get a p-value of 0.1146. Okay, that p-value is definitely bigger than 0.05, right? So p is greater than alpha, meaning our sample results occur, right? Sample results like this occur about 11.5% of the time. That's not rare enough. We needed something less than 5%. So since that is the case, we fail to reject the null hypothesis. Okay, what does it mean when we fail to reject the null? Again, we do not embrace it. We don't say that that's definitely true. All we say is we don't have statistically significant evidence to suggest the alternative is true, right? We haven't proven this guilty. So we haven't been able to say that the diameter of these dimes is something other than 1.9. We don't assume that the machine is working just fine. Right? We don't claim that this is actually true. We just say we fail to reject it. We didn't come up with enough evidence to say otherwise. All right, that's the idea of a one-sample t-test.